Hey everybody. So today we're going to work on understanding the simple machines of the inclined plane, the wedge, and the screw, okay, and going over those formulas. So let's see if I know how to click and move on here. So we've done already, and we had a previous presentation on how to get the simple machines and getting the formulas for the other ones. We're going to cover these three now, okay? Remember about mechanical advantage, which we already talked about, is how it's either going to be how many times easier it is to do something, or how many times greater a distance you have to travel to do it. We've already gone over the formulas, and if you don't know these formulas, go back to one of the other presentations on it. All right, so we've already talked about this. I'm going to skip this again. We're talking about mechanical advantage again. So it's greater than 1, equal to 1, or less than 1. I've talked about that. I'm going to skip that as well. So the equation is going to be I'm a deer for IMA. So IMA is going to be DE over DR. I've already talked about that in the previous slide, so I'm going to skip that. AMA is going to be the resistance force over the effort force. Okay, I'm still going. So here's our inclined plane. And again, remember, with any simple machine, if you increase the distance, you decrease the force. No matter what, to get up to the top of a ramp, you're going to do the same amount of work. Okay, the work is the same. It's either going to be a longer distance, okay, and a smaller force, or a shorter distance and a greater force. So that's always the trade-off with simple machines. Okay, with an inclined plane, it's pretty easy to see. If I go up a ramp, I'm going to travel a longer distance to get there, but it'll take less force to do it. If I pick something straight up, if I pick myself straight up, there's more force that I need to do it, but I'll travel a shorter distance. All right, next. There. So the IMA is going to be simple, okay? It's just going to be the length of the slope is going to be your effort distance, because that's the way you go up. That's the effort you'll be put in is going up that slope over the height. Okay, so it's still DE over DR, but we just have to be aware that the effort distance is DE and the resistance distance is going to be DR. Okay, it's going to be going up. So doing our calculation there, we have an IMA that's going to be 15 feet divided by 4 feet, and we're going to get our slope there. Okay, and it's rounded to 3.8 to 1. All right, moving on. Okay, now what about our AMA? So if I give you that there's 15 pounds in that wagon and you have to push with 20 pounds of force, then you're going to again do AMA is FR over FE. The resistance force was 50 pounds. That's what had to get lifted. The 20 pounds you have to push up the ramp is your effort. So 50 divided by 20, you get 2.5. Okay, now how about our efficiency? Remember that efficiency is going to be AMA divided by IMA. So our AMA in this case was what we just calculated, 2.5. Okay, our IMA was 3.75. You divide it out and you're going to get an efficiency of, if I'm in the way there, 67%. Okay? All right, so moving on again. All right, now a wedge, the idea with a wedge is that it's going to split, it's going to redirect the forces. In some ways, a simple machine wedge is more about the redirection of forces from going down to out. It can make your job easier, and you can have an IMA greater than 1, but sometimes it's not about getting an IMA greater than 1. It's more about redirecting the forces. You hammer something down hard, and it's going to redirect it to split, say, a log or something like that. Okay? Now, let's check it out. For this here, so notice how your DE, your effort distance, would be the distance traveled straight down. Okay, it's perpendicular to the height. It's not going to be the slope. It's going to be perpendicular to the height. So I drive something straight down. The DE would be that length straight down. The DR, the resistance distance, would be the perpendicular piece of that, the perpendicular to the height, the flat piece going across. So in this case, our length is 10, that would be DE. Our DR is 3 inches, okay? And that would be driven straight down, all right? To calculate the IMA, it would be 10 divided by 3, or 3.3 to 1. All right. Now, what about AMA? So I'm given 250 pounds, and I'm given that it's going to split 700 pounds. And so it's going out 700 pounds. Don't worry about it, 700 plus 700. That's not the case, okay? But you're going to take the 250 going down. That would be your effort force. And you get out of it 700, okay? That's a good thing. So FR divided by FE, you get 700 divided by 250, and you get 2.8. All right, again, let's practice how we get our efficiency. It's going to be our AMA divided by our IMA. Our AMA, we just said, is 2.8. Our IMA was going to be 3.33. So we just divide it out and we get, I'll get in the way there, 87%. Next. All right, now a screw. As a student, I never really understood why a screw is a simple machine, but really a screw is just a ramp. It's a ramp that's being spun around itself. So this picture shows a nice example of how to think of it, where that screw is really a ramp. If you notice, if you took a piece of paper, let's say you made a triangle with a sheet of paper and you wrapped it around the pencil. As you wrapped it around, it's still a ramp, but it's just spiraling and changing direction here. But there's going to be our simple machine. Now, to figure out, I want you to notice that the pitch is going to be the distance between each thread of the screw. And the pitch is going to be very important. So the pitch is how far the screw goes down for one revolution going around. Okay? So I will say this, a couple things to note about screws. Screws have a really, really high IMA. Okay? That's great. But screws really have a high amount of friction, okay, which is actually good too. If you want to have two things hold together, if you use a screw, it's going to have a whole lot of friction, obviously, and that's good, so it won't loosen up easily. Where that also means, though, is that the efficiency will be very low with a screw because you're not going to get you're not going to be easily screwing that in. You're going to see a lot of friction, but that friction can be helpful, like I said, to hold things together. All right, so let's look at that screw and the calculation for IMA versus AMA. All right, so the pitch, again, is the distance that a screw goes down. So if I make one full 360-degree turn, the pitch is how far down it went. So that's going to be your resistance distance, okay? Your effort distance is going in a circle now, okay? And that circle traveled is going to be whatever the circumference is traveling around. If I had a screwdriver turning in a screw, that's going to be a circumference, that's going to be the circumference of the handle. If I say had a wrench and I had a bigger radius on there, the circumference is going to be bigger and I'd have a bigger effort distance, okay? So the way we're going to look at it, all right, understand this, if you have 13 threads per inch, then when you read this, okay, that means the pitch is going to be 1/13 of an inch. So what does that mean, right? So it counts. The way they have information on screws is we have something like this. So we have the 1/2 that talks about the diameter of the actual bolt or screw. Then you're going to see a value there. So in this case, the 13 says that there will be 13 threads within a 1-inch distance, okay? So to divide it out, that means for every pitch down, it's going to be 1/13 of an inch. Okay, so the pitch of this is 1/13 of an inch. All right, so let's look at this. And now notice how it says effort arm distance. It all depends. If you got a screwdriver, again, the circumference is going to be about here. If you have a wrench, it's going to be a much bigger circumference to it. Okay, so here we go. The IMA is going to be, as always, is DE over DR. The DE is going to be the circumference of whatever you're traveling, whether it's a screw or a screwdriver or wrench or whatever, and that's going to be 2 times pi times r. All right, the pitch is P, right? It's going to be whatever we get the pitch to be, and that's usually so many things, it's going to be like in before it was 1/13 of an inch, okay? So you're just going to do circumference divided by pitch to get the IMA of that screw, all right? So notice the IMA of this bolt is 1,000. I know it's in scientific terms, but that's 1,000. That's a really, really high IMA. the AMA is not going to be as high. All right, so let's look at the AMA for this. Okay, so if we have, let's say there's an 8-inch wrench handle that we're turning, okay, then that was what, going back to it there, okay, we had 8 inches wrench handle. That was for the IMA. Now the AMA, if I am going to use 35 pounds of force to rotate something, okay, but it's going to do 1,200 pounds of force, that's still a good difference, right? So we're going to do 1,200 divided by 35. We get an AMA of 34.29. Okay, go ahead and calculate that and check and make sure you get the right answer. Okay, now that's really a big AMA, but what was our IMA? Our IMA was 1,000. Okay, because there's going to be a lot of friction with that bolt. So you take those values, 34.29 divided by 1,000, or 1,005.3, divide that out, and you get an efficiency of only 3%. Okay, so that's the idea. If you want to do something really, really easily, an AMA will be helpful. You'll see a screw with lifting up garage doors. Okay, some of you will have a screw drive for your garage door. There's a lot of things that use screws, a jack to lift up a car. But there's also going to be a lot of friction, which is good because if you pull it up, you don't want it to slide back down. You want that friction to hold. All right. Now, compound machines, a reminder, and I did this before in the previous slide. Compound machines, you're going to multiply all the mechanical advantages together. So if you have more than one compound machine or more than one simple machine working together, that's a compound machine. You get the IMAs of each simple machine and multiply them together, and that'll be the compound machine's mechanical advantage. Okay, that's it. Thanks so much for watching, and I'll see you later.